Okay, in this example, I'm going to talk about the difference between a constant integer pointer and an integer pointer constant. I'm declaring three integers right here. And so we have num, and then we have num1 and num2. You'll see that num1 is 0. And then I have a constant integer pointer, pointer1. So that's whenever you see a declaration like this, typically if you read it from right to left, it'll make sense. So this is a pointer to an integer that's constant. Pointer2 is a pointer to a constant of type integer. So these are both pointers to constant integers. Then pointer3 is a constant pointer to an integer. So I'll print the initial values of the numbers and also the pointers just to see where we're starting with. Looks like I'm trying to print num3. I don't have a num3, so I'll fix that. So now if I run this, you can see that I have three pointers. They all are pointing to the same value, and that value is 0. It may be interesting, as well as seeing the value it's holding and its dereference. It might be interested to see its actual address as well, just to show you that they're different. So I'll change these. So yeah, that should give us a little bit more information as we print this out. Let's set pointer1 equal to num1, pointer2 equal to num2, and let's do pointer3. We don't have number 3, but we won't need it. We'll do number 1. So let's try to compile this. And you'll see we get assignment of read-only variable pointer3. So pointer3 is a constant. The type of it doesn't matter. It's a constant. So therefore, we can't reassign it later on. So I'll comment this out, and I'll note that this is an error. We can't assign to a constant pointer. Now notice we're changing the pointer, not the value that's being pointed to. Pointer3, since it's constant, is always going to point to num. So we'll print out our three pointer values again. When we compile and run this, you'll see that we have our numbers here, and then these values stay the same. This is the addresses, but notice now what they point to is all different now. And pointer3 is still pointed to num because we can't change that. I also notice that there's no inlines here, so let me add that. Okay, so we've tried to assign these to a different value. Now let's try to change what they're pointing to. So if I say pointer1 is equal to 1, 2, 3, 4 ones, pointer2 is equal to a few of those, and then we'll say pointer3 is equal to 3, 3, 3. And then once we're done, actually let's also print what we're doing here. So I'm assigning a new address value to the pointer. And then here, I'm assigning a new value to the dereference pointer. So let's compile this and see what happens. And you'll notice I get an error. First off, I'm missing a semicolon somewhere, which is right here. So let's clear that up first, just so it's clear that we only have the one. One more of those. So now that we should get the errors we're looking for. Yes, so assignment of read-only location, pointer1. Now notice, pointer1 is pointing to num1, which is not a constant. However, it's a pointer to a constant int, meaning I'm going to treat whatever it's pointing to as a constant int. So I can't do this, and I can't do this, because you can't modify the value, I'll just say value, pointed to by pointer1 because it's a constant pointer. And the same, or it's a pointer to a constant. And the same for pointer2, it's a pointer to a constant. In short, when I have a constant pointer, which we have here, I can't change the variable that the pointer is pointing to. It has to point to the same thing the entire time. Whereas with a pointer to a constant, I can change what it's pointing to, but I can't change the value of what it's pointing to. It can point to anything I want. However, I can't change that thing using this pointer. So it's a real subtle difference, but it is important and it can cause problems if you're expecting one or the other of the two behaviors. So that's an example of constant pointers in C++.